Welcome to Maths and Science by IITIAN channel. In this lecture, I will be taking up a very good problem involving Chinese Remainder Theorem, that is CRT. Chinese Remainder Theorem. We will be using this theorem to compute and solve the system of congruences, that is x equivalent to 7 mod 11 and x equivalent to 11 mod 13 and x equivalent 7 mod 23. These three are system of congruence. We will be solving it and getting a solution in the form of x, a common solution in the form of x equivalent a mod m, where m is the overall modulus of the system of congruences. In this lecture, we will be applying the principle of Chinese Remainder Theorem, congruence modulo, and finding the overall modulus of the given system of congruences, and to apply the principle of multiplicative inverse, modular inverse, multiplicative modular inverse, to arrive at a common solution of x equivalent to a mod m, where m is the overall modulus. It's a very good problem. We'll try to solve it, and we are using very good 3-4 concepts, number theory concepts in this problem. Please pay attention to each of them. Please see the video till the end, and if you feel there is a value addition because of this lecture to you, kindly hype this video, kindly share and subscribe to my channel. Maths and Science by IITIAN. Let's move further. What is the question given here? Find, or we can even rather say solve, the given congruence system. What is this congruences given? System of congruence, x equivalent 7 mod 11, x equivalent 11 mod 13, x equivalent 17 mod 23. Let's go for the solution. If you look at these congruence, 7, 11, 11, 13, 17 and 23 are co-prime to each other. 7, 11, 13, 17, 23 are prime numbers and co-prime to each other. This is our first observation. And what are the moduli? Moduli are 11 is the moduli, 11, 13 and 23. These three are the moduli. This is the moduli 11, 13 and 23. Then what is overall modulus? Overall modulus is equal to m is equal to 11 into product of these moduli. 11 into 13 into 23. That is equal to 3289. What we are required to find out here? We have to find out a congruence common solution as x is equal to a mod overall moduli m. Here we got overall modulus as m is equal to 3289. Now the problem is reduced to finding this x modulo x equivalent a mod 3289. Here we have to find the value of a. How much? This is what is the problem. Now, what are the reminders given in the problem? Reminders in each congruence are R1, R2 and R3. What are they? 7 is R1, 11 is R2, 17 is R3. 7, 11 and 17 are 7, 11 and 17. Now, we will apply the most famous Chinese Remainder Theorem to get the solution. Here, there is a famous equation, that is x equivalent R1 M1 A1 plus R2 M2 A2 plus R3 M3 A3. Whatever may be number A3, A4, R2, R4, M4, A4 mod capital M. This is overall modulus. This is the Chinese Remainder Theorem principle. This is Chinese. Please remember this one. In congruence manner, it is expressed this way. Let us explain each and every element here. On right hand side, R1, sorry, we will change the color of the pen. R1, R2, R3 are remainders in given congruence system. A congruence system is given. In that congruence system, the remainders are given. The remainders, here the remainders are R1 is equal to 7, R2 is equal to 11, R3 is equal to 17 from the congruence whatever are given. Now, what is M1? M1 is equal to overall modulus by mod of 1. Here what is the equation 1 given? First congruence, x equivalent 7 mod 11. Hence, this value 11 is the first mod. Then this becomes overall modulus by 11. M2 is equal to overall modulus by second mod. That is, the given equation is second equation x equivalent 11 mod 13. Let this 13 be put here. M by 13. Then, what is M3? M3 is equal to overall modulus by third mod. Third equation mod. That is, there can be n equations. Fourth mod, fifth mod. Because I am writing this like third mod. Then it will be m by 23. Because the equation is x equivalent, third equation is 17 mod 23. Now, here we know the value of m. M is equal to first mod into second mod into third mod. That is overall modulus 11 into 13 into 23. That implies m is equal to 3289. That implies, what are the values of m1? m1 is equal to 3289 by 11. 3289 by 11 is how much? 299. M2 is equal to 3289 by 13. That is 253. M3 is equal to 3289 by 23. That is equal to 143. We have, what is the equation of Chinese remainder theorem equation? X equivalent R1 M1 A1 plus R2 M2 A2 plus R3 M3 A3 mod overall modulus. Here what it becomes now? It is simplified to, we know the values of R1. We know the values of M1. What we have to find out is, we know the value of R1, we know the value of M1, this is not known, here also R2, M2 is known, A2 is not known, R3, M3 is known, A3 is not known. Now we have to find out A1, A2, A3. For that, as per the Chinese Remainder Theorem principles, the most important step and most important calculation here it is involved is that we have to find A1, A2 and A3 such that M1 into A1 is equivalent to 1 mod the first mod. What is the first mod value? 11. M2 into A2 is equivalent to 1 mod second mod. What is the second mod? Second mod is 13. M3 A3 equivalent 1 mod 23. That means, what is M1 here? 299. 299 A1 equivalent 1 mod 11. This is all as per the Chinese Remainder Theorem. These are all steps required. M2 is 253. 253 A2 is equivalent to 1 mod 13. And third M3 is 143. A3 is equivalent to 1 mod 23. Because we have to find A1, A2, A3. For that we are doing this exercise. Very important step. Please try to understand. Now, how to find out A1, A2, A3 if this is the equation given? Here 299 into A1, 253 into A2, 143 into A3. Now first we will take up 299 into A1 equivalent 1 mod 11. How to solve for A1? That means A1 is equal to how much? If this is the equation. Now, here let us take 299. Here comes the principle of multiplicative inverse, modular multiplicative inverse. Now you just see, 299 is equal to 297 plus 2. Do you agree? 297 is nothing but 27 into 11 plus 2. That means when 299 is divided by 11, there will be a remainder of 2. That means 299 equivalent to mod 11. And we have another equation, 299 into A1 equivalent 1 mod 11. From these two, we will get instead of 299, we will replace it with 2. Then it becomes 2A1 is 1 mod 11. That means when 2A1 is divided by 11, there is a remainder of 1. That implies 2A1 divided by 11 produces 1 as remainder. That means 2A1 should be more than 11. Let us say 2A1 is equal to 12. That means 12 equivalent 1 mod 11. Do you agree? That implies 2A1 is equal to 12. That implies A1 is equal to 6. That means A1 is 6 here. The answer for A1 is 6. Next, we will take up 253A2. 253 into A2 equivalent 1 mod 13. That implies here what is 253? 253 can be written as 247 plus 6. 247 is nothing but 19 into 13 plus 6. So that 253 equivalent 6 is the remainder here, mod 13. What is another equation? 253 into A2 is equivalent 1 mod 13. From these two, what we get? Similarly from above, as we have got in the previous one, we got the 6 and 253. You replace with each other, we will get the answer 6A2 is equivalent to 1 mod 13. When you divide 6a2 by 13 gives a remainder of 1. 6 into 11 is 66 and 13 into 5 is 65, remainder is 1, which implies A2 is equal to 11. Similarly, the way we have calculated earlier. These are all simple arithmetic which you can do very easily. Next, 143A3, we will take that. 143 into A3 equivalent 1 mod 23. Now, how do you write 143 in terms of mod 23? $143 is equal to 23 into 6 plus 5. What is 23 into 6? 138. 138 plus 5. We can even write this way. 138 plus 5. That is equal to 23 into 6 plus 5. That implies 143 equivalent to 5 mod 23. Another equation we have got is 143A3 equivalent 1 mod 23. Now, you just check these two. 143A3 this implies these two. From these two, we get 143A3 equivalent to 5 no 143 253 6 into A2. Similarly, sorry, we made a wrong step here. 143 is taken, it should not be considered again. 143 is gone. 5 into A3. 5 into A3 is equivalent to 1 mod 23. Now, when it implies when 5A3 is divided by 23, remainder, it gives a remainder of 1. For which value of A3 it will be possible? For example, 23 into 3 is 69. 5 into 14 is 70. So that for A3, 5 into 14 is equal to 70, that is equal to 60, 29, 23 into 3 plus 1, 69 plus 1. That implies A3 is equal to 14. 5A3 is equal to 5 into 14, A3 is equal to 14. Now we have got the values. A1 is equal to 6, A2 is equal to 11, A1 is equal to 6, A2 is equal to 11 and A3 is equal to 14. Now ultimately, what is this value? X equivalent M1 A1 R1 M1 A1 plus R2 M2 A2 R1 M1 A1 plus R2 M2 A2 plus R3 M3 A3 mod capital M overall modulus. Now we have got all the values. R1 is 7, M1 is 299, A1 is 6. Now, by substituting these values, X equivalent R1 is 7, 7 into 299 into 6 plus R2 is 11, 11 into 253 M2 into A2 is 11 plus R3 17 into M3 143 into 14 mod 3289. Now this is nothing but when you calculate this value, it will be X equivalent 77205 mod 3289. Now we have to simplify it. Double 7205, how we can write? 77205 is equal to 3289 into 23 plus, we can even write it as, in term 3289 you divide, simple way I will tell you, 77205 you divide by 3289, it is a very simple arithmetic. 77205 divided by 3289, that is equal to 77205 divided by 3289 that gives 23 plus some remainder, which we are not aware. That means 77205 is equal to 23 into 3289 plus some remainder. That remainder we have to find out. That remainder will be 77205 minus 23 into 3289. Let us see how much it will be. It is a very simple calculation. That is 1558. Hence, the value of x can be written as the solution for the system of congruences is 1558 mod 3289. This is the answer. In this we have used congruence modulo principles, theorems, Chinese Remainder Theorem, CRT, and modular, multiplicative inverse, methods we have applied, and we got the answer by applying the basic congruence modulo theorem and principles and definitions. This is the answer for the given congruence system. This is how we have to find out the solution for the congruence system. It is a 3 equations are given, 3 congruences are given here, congruence modulo equations. If 2 are given also, the same procedure to be adopted. In the next class, we will be looking into finding a solution for quadratic equation. For example, x equivalent ax square plus bx plus c. Not quadratic equation, an equation in squares, polynomial equation. Can we do that? Let us try to do it in the next lecture. If you have added any value to your knowledge because of this lecture, if value addition is there, kindly hype this lecture, kindly share this lecture and subscribe to my channel Maths and Science by IITIAN. I want to conclude this lecture now, and best of luck to everybody. Thank you for listening to me. Thank you for seeing my lecture. Best of luck.